Dear students, today let us begin a new chapter, that is chapter 12, areas related to circles. You have already learned in your lower classes how to find the area and perimeter of simple plane figures such as rectangles, squares, parallelograms, etc. Is it? And also you have learned how to find the area and perimeter of circles also. Is it, children? So in this chapter, first of all, we will recall how to find the area and perimeter of the circle, and later we will apply this knowledge to find the area and perimeter of two special parts of circles such as sector and segment. Okay. So, as you all know, perimeter of circle is nothing but the circumference of a circle, is it? And what is the formula for finding the circumference of a circle? S 2 pi r, which means we can find the length of the boundary of the circle using 2 pi r. And what is the formula for finding the area of a circle? S pi r square, and pi takes the value 22 by 7 or 3.14, is it? Okay. Now let us see few questions based on this. Okay. Now let us see a question. The cost of fencing a circular field at the rate of rupees 24 per meter is rupees 5,280. The field is to be plowed at the rate of rupees 0.50 per meter square. Find the cost of plowing the field. Is it? Okay. So here it is a circular field. Is it? And we have to find the cost of plowing the field here. Is it? For that they have given us some conditions. Is it? What is the first condition? The cost of fencing a circular field at the rate of rupees 24 per meter is rupees 5,280. Fencing means you know what is that. Is it? So using this condition, we can find the length of the circular field, which is the circumference of the circle. Is it clear? Okay, so how can we find this? The total cost is rupees 5,280, and for 1 meter it is rupees 24. So how can we find S? Total cost divided by cost for 1 meter, is it? So length of the fence is equal to rupees 5,280 divided by rupees 24. Is it? That is equal to 220. What is that, children? 220 meter. So we got 220 meter. Is it? This is the length of the fence, which means the circumference of the circle. Is it? So we got circumference of the circle is equal to 220. Okay. So now what is circumference of a circle? S 2 pi r. Is it? So how can we write? 2 pi r is equal to 220. Is it? So from here 2 into 22 by 7 into r is equal to 220. Here we have to find the radius. Is it? So we can take all of the terms to the other side. So what you will have? R is equal to 220 into 7 divided by 2 into 22. So here we can cancel it. How much? 10. Again 5. Therefore R is equal to 35. So we got the radius is equal to 35 meter. Okay. Now the field is to be plowed at the rate of rupees 0.50 per meter square. Find the cost of plowing the field. So first of all, we have to find the area to be plowed. Is it, children? For 1 meter square it is 50 paise. Yes or no? So we have to find what is the total meter square, then into 0.50. Is it? So for that, what you have to find is the area of the field. So area of the circular field, that is nothing but area of field is equal to pi r square, that is 22 by 7 into 35 into 35. 7 and 35 we can cancel 5 times. So the answer will be how much? 3,850 meters square. So this is the area of the circular field. Okay. So for 1 meter square it is 0.50. I said, so what will be the total cost for this? Yes, we'll see. What is that? Total cost of flowing is equal to 3850 into 0.50. That is equal to 1925. So what is the amount? Rupees 1925. Clear? Now the next question. The radii of two circles are 19 cm and 9 cm respectively. Find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. Okay. So you just see here two circles are given to us and their radii are 19 cm and 9 cm. Is it? So let the radius of first circle be R1 and radius of second circle be R2. Okay. So R1 is equal to 19 centimeter and R2 is equal to 9 centimeter. Okay. Now find the radius of the circle which has a circumference equal to the sum of the circumference of two circles. So there is a third circle. Is it? And we have to find the radius of that third circle. For that a condition is given to us. What is that? S. The circumference of the third circle is equal to the sum of the circumference of the first two circles. Is it, children? So here, since there is a third circle, we are going to take that R3 be the radius of the third circle, which we have to find here. Okay. So from the condition we know that circumference of third circle is equal to the sum of the circumference of first two circles. Yes or no? Yes, is it? Okay, now here 2 pi is common, is it, children? So 2 pi R3 is equal to 2 pi into R1 plus R2. Now you see 2 pi will get cancelled. And what is that? R3 is equal to 19 plus 9. That is R3 is equal to 28 centimeter. Therefore, the radius of the third circle is 28 centimeter. Okay. The next question. The diameter of the wheel is 1.26 meter. What is the distance covered in 500 revolutions? So here you all know the wheel is in the form of a circle. And here the diameter of the wheel is given to us 1.26 meter. That is diameter is equal to 1.26 meter. We have to find the distance covered in 500 revolutions. So what is the distance covered in one revolution? One revolution is nothing but is equal to the circumference of the circle. So how can we write? Distance covered in one revolution is equal to circumference. Is or no, children? Okay. Now what is circumference of the circle? S 2 pi r. 2 pi r. Here diameter is given to us. Here it is 2 pi r. You just see what is 2 into r? It is nothing but diameter. So 2r is diameter. So how can we write? Can we write it as pi into d? Yes, is it? It is nothing but pi into 1.26. Is it clear? We can keep as it is. At last we will substitute the pi value. Okay. Now this is the distance covered in one revolution. Our question is in 500 revolutions. So what you have to do? Into 500, is it? So distance covered in 500 revolutions is equal to 500 into pi into 1.26, is it? It is nothing but 500 into 22 by 7 into 1.26. Here I have taken pi is equal to 22 by 7. Let's see. If in the question the pi value is not mentioned, we can take it as 22 by 7. If it is mentioned as 3.14, you have to take the same 3.14 itself. Okay. So here we have to multiply and get the answer, is it? So when we multiply, we will get it as 13,860 divided by 7 equal to 1,980 meter. So this is the distance covered by the wheel in 500 revolutions. Moving to the next topic, as I told you, there are two special parts of a circle, is it? They are sector and segment. So first of all, we will see what is sector of a circle. Okay, sector. You have learned this last year, is it? So what is sector? Is the part of a circular region between two radii and the corresponding arc. Okay, suppose this is a circle with center O. Okay, children. Now, if we draw two radii, okay, this OA and OB are two radii and AB is the corresponding arc. Is it? Now, there is a region or part of a circular region between this. Is it? We will call this as sector. Is it clear? So, a sector is a part of a circular region between two radii and the corresponding arc. Okay. Now, you just see this is also a part of region between two radii and corresponding arc. Is it, children? So, there are two sectors. We will name it as major sector. The larger area we will call it as major sector and the smaller one minor sector. Is it clear? Major sector and minor sector. Okay. Now how we will name it? You just see, for identifying the major and minor sectors, we can give one more letters. Okay. That is this point as P and this point as Q. Okay, now from this, which is the minor sector? O, A, P, B. Is it? Is this the minor sector? S. And which is the major sector? O, A, Q, B. This is the major sector. Is it clear? Sector S. Okay. The next one is segment. Is it? What is that, children? Segment. Okay. Now what is a segment? A segment is a part of a circular region between a chord and the corresponding arc. Okay, so you all know what is a chord, is it, children? So if we have a chord like this, AB, okay, now you just see there is a part of region between the chord and the corresponding arc. Say this region we will call it as segment. The same as in sector, here also we have a larger segment and a smaller segment. Is it? So the larger segment we will call it as major segment and the smaller one minor segment. Okay, children. Okay. Now you just see here, we have to name the segments. Is it? Let it be P and let it be Q. Okay. Now name the minor segment S. A, P, B. This is the minor segment. And the major segment A, Q, B. This is the major segment. Okay. Also one more point. In sector, here it makes an angle. So, children? Yes. The total angle is 360 degree. And here it makes an angle. We will denote it as theta. Okay. Now, here this is theta, is it? Then what will be this angle? S 360 minus theta. Is it clear? Next, we will learn the formula to find the area of sector. Okay. So, as we know, OAB is a sector and here let the angle be theta. Okay. Now, you know area of the circle is equal to pi r square, is it? So, here we have to find the area of this minor sector. Okay. So, how can we find that? Means, out of this 360 degree, this angle is theta. Is it? So, the formula is for minor sector. Okay. Area of minor sector, how can you find? Means, theta by 360 into pi r square. Okay. Now for major sector. So this is major sector. Is it, student? Okay. Here the angle is theta. Then what will be this angle? S 360 minus theta. Is it 360 degree minus theta. So how can we find the area of this major sector? Out of 360 degree, this angle is 360 minus theta, is it? So how can you write 360 degree minus theta by 360 into pi r square. Okay, this is one of the method. Okay children, see, or else for finding the area of major sector, this is a circle, is it? So from this circle, if we subtract this area of minor sector, what do we get? Do we get the area of major sector? S, is it? So, or else you can use area of circle, that is pi r square minus area of minor sector. So, you can use any one of this formula. Next, we will learn the formula for finding the length of an arc of a minor sector and a major sector. Okay, you just see here this APB is the length of an arc of a minor sector. Is it children? So how can we find this? Okay, so if it is the circumference, we know 2 pi r. Is it? So here this length is for this angle theta. Is it children? So out of 360 degree, we are going to consider only for theta. Is it? So the length of an arc of a minor sector is equal to theta by 360 into 2 pi r. Okay. Now in the case of major sector, the arc of a major sector. Okay children. So we know the angle is 360 minus theta. So how can we write S? 360 minus theta by 360 into 2 pi r. Is it clear? So the length of an arc of a major sector is equal to 360 minus theta by 360 into 2 pi r. Okay, or else we can use one more formula. What is that? See, this entire length is 2 pi r, is it? So from this circumference, if we subtract the length of the arc of a minor sector, do we get the remaining? Yes, is it? So we can write circumference of the circle minus length of arc of a minor sector also, is it? So the next formula is 2 pi r minus theta by 360 into 2 pi r. Is it clear? So any one we can use. Is it clear? Now we'll see one question. Find the area of a sector of a circle with radius 4 cm and of angle 30 degree. Also find the area of the corresponding major sector and use pi is equal to 3.14. Is it? So this is the question given to us. Here theta is equal to 30 degree and this is the minor sector. Here they have simply given a sector, as I told you, which means minor sector. Is it? So here you have to find the area. So what is the formula? Area of sector is equal to theta by 360 into pi r square. Now what is theta then? Yes, 30. 30 by 360 into 3.14 into, what is the radius given to us? 4. 4 into 4. Now 0, 0 got cancelled. 3 and 36, 12 times. 12 and 4, 3 times. Is it? So if we multiply, what you will get? 12.56 divided by 3. Okay. If we divide, we will get 4.19 centimeters square. This is the area of the minor sector. Okay. Also find the area of the corresponding major sector. Is it? So as I told you, two ways are there. The first way is what? Pi r square minus area of minor sector, or using the formula. Okay. Here, area of major sector is equal to area of circle minus area of sector. Okay, that is pi r square minus, already we have found what is the area of sector. So children, what is that? S. 4.19. Okay, now here 3.14 into 4 into 4 minus 4.19 is, when we multiply this we will get 50.24 minus 4.19. Okay, now if we subtract we will get 46.05 centimeters square. So this is the area of the major sector. Okay. Now the next question. What is the perimeter of the sector with radius 10.5 centimeter and sector angle 60 degree? Is it? So here you have to find the perimeter of the sector. So this is the sector. So perimeter means R plus length of the arc plus R. Is this the perimeter, children? Okay. Now we can write perimeter of the sector is equal to R plus length of the arc of sector plus R. Is it? Now what we have, 2R plus theta by 360 into 2 pi r. Is it? Now here 2r is common. So what will be there? 1 plus theta by 360 into 5. Okay. Now from here 2 into 10.5 into 1 plus 60 by 360 into 22 by 7. Okay. Now 2 into 10.5, 21 into 1 plus, we can simplify it as 1 by 6, is it? 1 by 6 into 22 by 7. Okay, so what you will have? 21 into 1 plus 22 by 42. Okay, now what you have? 21 into 1 plus 11 by 21. That is 21 into 21 plus 11 by 21. 21 got cancelled. So the answer is 32. Is it clear? 32 what? Centimeter. The perimeter of the sector is equal to 32 centimeter. Hope you understood today's portion. Thank you.